Hi everyone, in this video lecture we are going to learn about Quadrature Amplitude Modulation, that is QAM. Yes, me Sri Devi, Professor, Department of Electronics and Communication Engineering. On completion of this video lecture, the students can able to understand the principles and generation of Quadrature Amplitude Modulation. We know that the correct detection of signal depends upon the separation between the signal points in the signal space. Quadrature amplitude modulation is a method of combining two amplitude modulation signals into a single channel. One signal is called I signal, that is in phase signal, and the another one is called as Q signal, that is quadrature signal. So in phase and quadrature signals are combined and they are transmitting in a single channel. Mathematically, one of signals can be represented with a sine wave and the another one can be represented as cosine or cos wave. This is PSK signal has constant amplitude throughout. So if amplitude of the signal is varied, then it has the points lie inside the circle is also varies in the consultation diagram of ASK. So if you are increasing the points or Euclidean distance, the noise immunity of the system is also varies. So QAM is mainly used in microwave and telecommunication systems to transmit the information. So if you have 164 QAM and 256 QAM are used in digital capable television and cable modem. QAM is also used in optical fiber system to increase bit rates, and it is also used in Wi-Fi, digital video broadcast, that is DVB and Wi-Fi. These all are the applications of QAM. Already we said that QAM is the combination of one cosine and sine signals. So in this diagram, so one is the cosine signal and another one is the sine signal. Sine signal starts with the 0 point and cosine signal starts with the maximum point, that is called as 1. It is the combination of this both sine and cosine waveform. While talking about the geometrical representation, before listening to the advantages of QAM, the geometrical representation, we have to point out the Euclidean distance between QAM, or it is otherwise called as QASK signals. So the Euclidean distance between these two is determined by dQAM, that is equal to square root of 0.6 EB. EB is the energy per bit. So QAM is a signal in which two carriers shifted in phase and quadrature, that is by 90 degree. One is normal and another one is 90 degree phase shift. That is sine wave and cosine wave modulation are combined. So as a result of their 90 degree phase difference, they are in quadrature, and this gives rise to the name. Often one signal is called as in phase I and another one signal is called as quadrature Q. So the resultant overall signal consisting of combination of both I and Q contains both amplitude and phase variations. So in view of the fact that both amplitude and phase variations are present, it may also be considered as a mixture of amplitude and phase modulations. So it has some limitations, that is, it appears to increase the efficiency of transmission for a radio communication system by utilizing both amplitude and phase variations. It has some drawbacks, which is first one is it is more susceptible to noise because of the states that is closer to that lower level of noise. It need to the signal to take the decision point. So we are using some receivers. The frequency and the phase of the receiver after modulation both are having some limitations with the amplifiers. So they are able to remove any amplitude noise and thereby improve the noise reliance. So this QAM cannot do like this. That is, this is not in case with QAM. The second limitation is it is associated with the amplitude component of the signal. So when amplitude, that is when frequency and phase modulated signal is amplitude via one radio transmitter, there is no need to use the linear amplifiers because there is some relationship between both. It will access the linear amplifier inbuilt, whereas in using QAM we have to use the linear amplifiers. So it contains amplitude component, linearity must so that to maintain the linearity. Unfortunately, the linear amplifiers are less efficient. It is not fully efficient and consume more power, and it makes them to less attractive for mobile applications. So one QAM having 12 different phases are combined with 2 different amplitudes. So only 4 phase angles have only different 2 amplitudes. That is 2 power 4 equal to 16. So that 4 levels of phase angles we have. So this is the consultation diagram of QAM. So here we are representing different bits here. One is sine wave, another one is cosine wave. Both are combined, and combined wave is represented in here. 45-degree phase shift is considered 12 phase angles. So combination of ASK and PSK such that each signal correspond to multiple bits, more phases than amplitudes. So that is we have more phases, less amplitudes. That's the meaning of more phases than amplitudes. Minimum bandwidth recommended of QAM is same as that of ASK and FSK. And we have one quiz question based upon quadrature amplitude modulation, that is QAM uses as the dimensions. What the dimension set is uses in phase and quadrature both. It is not only quadrature, not only in phase, and correct answer is in phase and quadrature. Thank you.